All right, so last time we developed this idea that if you take a root of something to that same power, those two operations undo each other. That's the big idea. The only issue is if we're talking about even index raised to even power, you need absolute value bars. And if you need to convince yourself, kind of go back up and look at what we did kind of to develop this idea. But at the end of the day, that's what you have to know. So let's look at another example or so in using this idea. So number 2, again, let's do an A and a B just to kind of compare some things side by side. So let's say I had the 5th root, and let's say I had the quantity of x minus 1 to the 5th power. So here's one that even if I wanted to follow order of operations, I couldn't. In number 1, we had all numbers, so in theory, I mean, if I didn't have a calculator, that'd be a big pain, but in theory, you could multiply out those numbers and then take the appropriate root. But here you can't. So we just want to recognize, yes, if I have the 5th root of a whole quantity, a whole base there being raised to the 5th power, those two are going to undo each other, and I'm just going to get back to that base, which in this case, that base is x minus 1. Question is, do I need absolute value bars? No, I do not, because we had an odd number there with that 5. So it's just x minus 1. All right, but let's contrast that with, let's say I had the square root of x minus 1 quantity squared. So again, it's the implied index of 2 here, of course, the implied index of 2, and then something being raised to the 2nd power. And so when those match, yes, those two undo each other, and you're going to get what was that base, which in this case is x minus 1. The only question is, do I need the absolute value bars? Yes, I do here because I have 2, which is even. And then unlike number 1 part A, up here I could actually evaluate absolute value of negative 29. That was 29. Here I can't. I have a variable in there. So you just have to leave it. Can't simplify x minus 1. You just leave it as absolute value of x minus 1. All right, number 3. Let's say we had the cube root of, and let's say I had y to the 30th over c to the 36th. So this looks a whole lot different. So first thing we want to recognize is we can and will here think of this as the cube root of the numerator divided by the cube root of the denominator. So I have y to the 30th, cube root of y to the 30th divided by cube root of c to the 36th. Okay, now there will be other ways that we're going to learn to simplify these, but right now we really just have kind of one property that we've just learned, which is this. If I can get this as the cube root of something cubed, then I know that those two would undo each other and I would get what was left under that base. So I want to think about here, the idea is then y to what power cubed would be y to the 30th. Remembering that powers to powers you multiply, it is y to the 10th that when you raise it to the 3rd power would be equivalent to y to the 30th. So in this case then, the cube root of something cubed is just going to give you what was that base, which in this case, that base is itself y to the 10th. And then the same question, do I need absolute value bars, yes or no? In this case, no, because I have the odd number with that 3. All right, let's look at the same idea here in the denominator. So right now, we're just working with this basic idea here that says the cube root of something cubed, that those two would undo each other, and I would just get back to whatever that base would be. So here I want to think about c to what power cubed is 36. again, powers to powers we multiply, so that's going to be c to the 12, because 12 times 3 gets us back to c to the 36th. Now the cube root of something cubed is just that something. So we get our c to the 12th. Do I need absolute value bars? Again, no, because we have 3 here, which is odd. So you could have something like this in either an even or odd issue with our index and power, where you may or may not need the absolute value bars. Here we did not. All right, so our last topic of this section, I think I'll come back to in the next video, is domains of functions with radicals. So we'll come back to that next time.